Okay, on this problem, we want to solve or evaluate the integral from -3 to 7 of 4 dx. And in order to do this, we're going to want to look at a graph of this guy. So I'm going to go ahead and put a graph out here. Now, it doesn't need to be a super perfect identical graph to 4, but it's got to be a pretty good representation, and we want to have a kind of a good idea what's going on here. And man, that's horrible. I'm going to start over. Let me just get rid of all this. Okay. And OCD kids, I will take care of these two little awkward dots. Okay, those are gone. We're going to try again here. And the reason I want my axis to look halfway decent here is I need to know what's going on left and on right. And in order to determine that, I needed a little bit more on the left-hand side there, okay? So here we go. The line y equals 4. It's a straight line, and it's right there, horizontal line at 4. And again, you don't need to put in a bunch of tick marks and count them all off. We don't need to do that. But we do need to know about where -3 is, and there it is. And we need to know where 7 is, and there it is. And again, I don't need tick marks necessarily. I just need a rough idea of the shape I'm dealing with. And holy smokes, if I'm going to find the area under this shape to evaluate the integral, I'm finding the area of a rectangle, okay? And when I find the area of my rectangle, to find that area, I need two things, a base times a height. And so in order to do that, I just look, how long is my base? Well, if I go from 0 to -3, I move 3 spots. If I go from 0 to 7, I move 7 spots. And that whole base then is going to be 10. On the other hand, when I go up to my graph, I'm going from 0 all the way up to 4. That gives me the height for this guy. So how do I evaluate the integral? I find the area under the rectangle of the rectangle, which is 4 times 10, or 40. All right, here's a fun little problem going from evaluating the integral from -6 to 6 of 2x plus 12. And hey, I'm going to graph this guy out real quick. And just like with the other problems that we've done, you don't necessarily need to have a spot-on perfect graph. You just need to have a good idea of the general shape. We're going to have triangle, rectangle. What are we looking at? Trapezoid maybe. And so here we go. We're just going to graph 2x plus 12. That is going to be a line with a y-intercept of 12. And if you think about it, it's going to have positive slope of 2. And eventually it's got to cross the y-axis, or the x-axis. So in order to do that, I just set my 2x minus 6 plus 12. I'm just going to set that right there, equal to 0, and see what happens. Oh, it is 0. So there you go. There's where I cross the x-axis, is at -6. And then I'm going to also investigate this at the stop side, what's going on when x equals positive 6. So there's -6 tells me where I go from left, and positive 6 tells me where I go on right. And I have, voila, a triangle shape. So I'm going to find the area between the curve and the x-axis. All right, how do I find the area of a triangle? 1/2 base times height. So to find the area of the base, if you start at the origin and move to -6, you move 6 units. And if you start at the origin and move to the right, you move 6 units. Okay, there's my base. My base is 6 plus 6, or 12. Now, how do I find the height of my triangle here? Well, I need to know what the function is when it's evaluated at 6. So I need f of 6. Like, what is that? So I just do 2 times 6 plus 12. I'm just going to work that guy out real quick. And that's going to give me 24. Okay, 12 plus 12 is 24. That's my height. So guess what? I am now ready to find the area under this particular curve. It's just going to be 1/2 times 12 times 24. And you're going to punch this into your calculator, or hopefully you can do it without a calculator. I don't know. But you're going to end up with 144 as the total area under this particular curve. All right, question number 9. Evaluate the integral from -7 to 7 of the square root of 49 minus x squared dx. Well, let's graph this guy. And if you can remember back to your pre-calculus days and conic sections and all that, this has the rough makings of the top half of a circle. How do I know that? Well, I've seen 1 or 2 or 3 of these. And And so what we're going to do is we're just going to go from -7 to +7 on the x-axis. Believe it or not, we're going to go up to 7 on the y-axis. You can even graph this on your calculator and see what the shape is, but it's a half of a circle. So here we go, half a circle, drawing it out, and here we go, kind of more ellipse footballish, sorry. But regardless, this is the area that we're interested in, because the area under this circle is what our integral would be equal to. What is that? Well, the area of a circle is pi r squared. Well, I'm only dealing with half a circle, so I take half the area. It's that simple. What is my radius? Radius is that magic little 7 that you see all over the place, because I go from the origin up, left, and right 7 units for all parts of this guy, okay? So now what? Well, just plug 7 in for r, okay? And that's going to end up giving me then the area of a semicircle, which is going to be equal to pi times r, see it, r squared divided by 2, which is going to give us 49 over 2. And there's really nothing else that you need to say over this. 49 pi. You can decimal it if you want to. There's no need. Most answers are going to appear this way because it's an exact answer.